coordinator. So my work is to integrate the model to the open source community, such as what you are using, such as GLM or VLM framework. So the today talk is not mainly claiming the state of the art of our model. So instead, it's about a particular design of the choice and what I'm doing and what we team doing in how to make this model more popular in open source community. So before we start, we can maybe let me introduce my company first. We are Z.ai and we're from Beijing, and this is our roadmap of our company. And you can see we started out with 2019, and in 2021 we began to train the large scale language model, and we released GM 130B at that time, and that was the earliest open large scale model over 100B over China. And in 2023, we released model like Video GM and Chat GM. So it's covering the multimodal and the conversational using case. In 2024, we expanding the products. So we introduced GM4, our flagship model at that time. And also we try to do some agent work like AutoGen. In 2025, we introduced the more model, especially for MOE models such as GM 4.5 and 4.7. So this is our roadmap in our company develop. And here I will show a roadmap of our model group. You can see each arrows is connected to a different model. That means that they have connected. For example, it is developed by the earliest one. So here the purple one is the edge model and on devices model, and the white is for the chat model, and the pink is for the multimodal models, and for image generation and the video generation is the green one and the yellow one. So this is the whole map of our model matrix. And the first part, I will simply introduce all of this model. And the second part, I will introduce what we're doing in the open source community. So today we have released over 70 models, open weights model. And for all of these models, it's more than 16 million downloads and more than 1,500 projects open source in GitHub. This is mean that it's developed by our model or use our model to do their own project. So this is our word of the model. So we are always on the access. So first, let me introduce GM 4.7. It's our flagship model today, and they have two sides. One is a GM 4.7, and the other is GM 4.7 Flash, which is a lighter MOE model with only 30B and 3B to be fast and efficient. And both these two models are optimized to two key directions: is for coding and injecting tasks. So when GM 4.7 released, it achieved very strong performance among the open weights model, and especially on the coding task. So the goal is not just to solving the benchmark problem, but is to able to write the execute the real code to following the two code parameter and a complete multi-state class capability. So to be on the benchmark here, I have two examples of this model case. For one, we use end-to-end game generation task. So we asked GM 4.7 to build a complete game like a Plants vs Zombie. It's a very famous game on 10 years before, and we use the usage of search from the internet, and we tell them the logic of the game. So the text. This task is to test the model capability to handle a full form specific and to a working prototype the workflow. So it can work very successful using GM 4.7. And now is the front end page generation. We also use GM 4.7 to generate the clean web page with a structure. So producing a completely layout with a clear hierarchy and reusable components. This is a good proxy for a real developer workflow when the structure and the maintainability matter as much as correctness. We open source the training pipeline, especially for the reinforcement learning pipeline. So we open source the slide framework. This is open source. You can search in GitHub. So this is what we are still using in our reinforcement learning pipeline. And this is a design for flexibility and efficiency and the scalability. So you have three parts. One is the training part is using the based on the Metron, and the rollout is built on Zhang and have a routing layer. And the finally is a shared data buffer. So these components work together and support both single reason and filter reason modes. So for the generic reasoning and math task, the single reason mode can max efficient use of the GPUs, and for the more complex agent tasks, such as the software engineering and the workflow, and single reason mode prevents the training for blocking and while one GPU or one pipeline stop. So, and also to improve the efficiency when training, we design or using a BF16 or training and FPA for inference. So combined with online and chart-wide quantization. So this significantly speed up the rollout data generation. And through an unifying HTTP interface and critical data pool, Slime can seamlessly integrate different agent frameworks, so enable the multitask training and high quality data sampling. So let's move to the multimodal. We also open source the GLM 4.6 Vision. This is a image text-to-text model, and it performs very well in the popular benchmark. It supports the video more than 40 minutes and multi-image input. So we also open source a small apps that it provides on Hugging Face. It's a small open source apps, so help you to design or debug this model in your own local machine. So it is an app that can record your screen and take a screenshot and spin this to API, or to API you deploy your SGN or VN, or you also another type of OpenAI format API to help you. And you can control, you will use the keyboard, use the mouse to control computer to do a computer agent work as a Gen 4.6 vision. And the agriculture is like this. So for GM 4.6 vision, you have a vision tower MV2, and to add to the GM 49B with GM, this is a small one with a dense model GM 49B, and the bigger one, such as the Air one, use the GM 4.5 and 10 and 106 MOE model. So this is the structure of the GM vision. And also we provide GM image model for image generation. And here you can see the architecture of the GM image. So it's built an auto-regressive image initialized for GM4 9V 0414. So this means the model directly inherits the strong language understanding and the instruction following and the reasoning ability from a mature large language model backbone. So instead of designing a completely new agriculture for the image, we just deliver it to keep the minimal agriculture range for a large language model. We change the LLM head to a vision token, use a VQVAE here, and this makes training alignment and deployment much easy. Finally of this part, I want to introduce the AutoGen. This is an open source project with the open source model and the GitHub repos about how it can work using an ADB and other control parts to control your angel form. So it is open to use to help you to use the model to control your mobile. And here is an example of how it's working. So we provide the AutoGen model. It's an open weight model, so we deploy it, and also use our open reports to use it to install in a form, and you can connect to the API. You also using OpenAI format to connect with the AutoGen model, and then connect, and they will feedback using a screenshot and to do any do some operation on the phone, and that is the AutoGen using. And also we provide the ASR. ASR is, and also we have a product of the product to using a speech recognition. And this is the final I want to talk in this part. Okay, so let's move to the second part of this talking. So I will introduce the GM open source ecosystem, because it's not enough to just train the model, but it's also very important to make it more popular or make everyone know the model is suitable for their own environment when they're working. So let's go ahead. So there's some boring work I'm doing, and this is what I'm doing usually at times. So before release, we usually need to do a lot of pull requests. This is boring and repeatedly, but we do again and again. So for example, there are very famous there are lots of family framework in open source. For example, transformers. They are the basic because if you know support transformer inference, the VM, Echelon, Olama, and something, they need to read the agriculture from for transformer to inference model. So the first part is to adapt your model to transformer, usually with a model backbone, model architecture, your tokenization, tokenizer, and even sometimes for a multimodal processor to transformer one. And meanwhile, you can do the VM and HDR very quickly because they are now is in a different implement way, only read the config of the transformer. So after the transformer PR raise, you can write the VM and HDR with a different almost the pipeline is a little bit similar if you just write the model path, but for the kernel one or for another thing you need to optimize for your own model. This is you need to write by yourself. That is what I'm doing now. This pipeline show what we are doing before release and after release. So after model training, we get the model weight. This is using a Megatron or other formats in the inner of company. And so in a parallel, for the product, they do API interaction. They try to serve in their own API, but for open source, we do this adaptation to our open source community. And after this done, so we will update to the final model. At this time, the final model finish it. So we upload to the GitHub and Hugging Face and then open source. But the more important is the right part because a lot of developers now are using a model. So in this case, there were so many issues, pull requests, and other bad case, they will report and they will use any kind of thing, such as the GitHub issue or user feedback support tickets and lots of that thing. So they will feedback. So this will help you to determine that it is the bug of the infrastructure or like this is the most bad case. So it's help us. We will let some engineering to check and to improve our model at this time. So at the same time, developer will using this model to group the community product and to develop open source projects. So help the community more good. The final, we also do some text sharing and exchange events that we are doing continually. So we have a lot of activities such as the online and offline, for example, AMA after model release. So that we are doing. So you can try GLM on the web. This is the Z.ai. Z.ai is our website. And we also have a coding plan of this of our model. So you can use the coding plans to use the infrastructure of code or another code tools to use it. And finally, the important link is here. I put the blog of Gen 4.7 and the Gen 4.5, the technical report, and our GitHub of the all GM series model. So that is all of our presentation today. Thank you very much.
I guess there must be tons of questions. We only have time for one, so let's go.
Very short question. And you actually answered it in private, but it would be nice to have it here as well. How many people are working on the core model development?
This is hard to
roughly
give you exact time, but roughly that's 200 to 300.
200 to 300.
Yeah, they include the data and you can see our
training, quantization, the whole.
Yeah, but less detail I can't tell so much.
Of course.
Yeah.
Thank you.
So we spend you can say the main engineer of ours is about the training. There's just a few persons like me and doing the open source or another infrastructure working. So we spend the most people like doing the training job. So it's very hard.
There's a quick question. So Jenya, you have maybe a different question?
Well, if we have time.
Yeah.
So when you were thinking about the model design and deciding whether you do a native model pre-training or you use a pre-trained language core component, have you been doing anything like scaling load derivation on smaller scales to help the decision making, or just trying to shoot it?
We haven't tried the native multimodal one. You can see that Kimi K2 is a very good example.
I'll try it actually.
Us,
Yeah,
but yeah. We also use the Vision Tower one.
Okay.
Yeah.
So you never.
We've
Okay.
we have no plan very soon to try the negative one. Also using a vision tower.
So differently, as if you're now going to try it, would you use something like scaling law derivation to help you to figure out what is better to do? Or you have a more simpler technique to assure that you're doing the right interventions, basically?
Maybe I don't know this. Yeah, I haven't tried this before.
Okay, room for discussion. So last but not least, we have the people from Quen presenting. Oh, so let's thank the speaker again.